I take a dib on it?
Sure. Okay, everyone, welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother, Joel. We are here to hopefully show you how to approach SAT math questions. This is a math question from a calculator section, and Seth volunteered to take the first dip, and if he does it some weird way, then I'll do it another way.
Okay. Well, so the problem, approaching SAT questions. Hint one. Take use of approach it by identifying when something is defined as something else. As they define X as the average of M and 9. It's an average of two numbers. Is their sum divided by 2? So there we use the if X is the average of M and 9. Similarly, there's a comma. See the comma. It moves on to an independent statement. Y is the average of 2M and 15. So we write it out. And Z is the average of 3M and 18. Let me erase. I like to erase, not cross out.
I like to cross out.
When showing people. And now, the question is, what is the average of X, Y, and Z in terms of M? Well, the average of X, Y, Z is X plus Y plus Z. Whatever that is, divided by 3. All right, so you add up everything here, divide by 3. So let's add up the M terms. 1M plus 2M plus is 3M. 3M plus 3M is 6M. 6M divided by 2 is 3M. Now, we add up these stupid... I don't want to add up those numbers. Let's look at the answers. There's only one answer where the M appears with a multiple of M. So it has to be this one. If you want to check that the SAT makers didn't make a mistake, we could take the time to add up the other numbers. And I bet a nickel that's going to come out to 21.
So should we embarrass Seth or not? No, okay, fine. First of all, that's not how I would approach it, which is good. We're coming from different approaches, okay? Which is really
I didn't
good.
Divide. Did I make a mistake?
Yeah,
I didn't divide by...
You made a mistake.
I didn't divide by 2 and I didn't divide by 3.
You didn't divide by 3 over here.
Yeah, oh well. I divided this by 2, and I forgot to divide it by 3.
That's right.
So it's M. So I cannot use that strategy. It's one of these answers, and now I actually do have to add up these things to tell whether it's 6 or 7. Sorry, Charlie. Yeah, overconfidence. Yeah, overconfidence, like the rabbit, the rabbit racing each other, the hare. Tried to, took a short, it was lazy, took a nap, he tried to do it fast, and the tortoise beat him. Well, that's what happens when you have to watch out for it, SAT questions.
Yes, you do. Yes, you do. Yes, you do.
Yes, you do.
Yes, you do.
Oh, well. Embarrassing.
Yeah. So now let me show you how I would have done it. Well, so we don't really know the answer yet, right? Do you want to just finish it off?
Yeah, well, here's another trick you could do. See if the constant term is even or odd.
Okay, just do whatever you want to do. Get the answer. Let me try.
Okay. Well, the constant term is the three numbers now, 9, 15 plus 18 divided by 6.
Okay, Seth, your brain is shot, clearly. That number is 42. Okay,
Okay.
so it's 42 divided by 6, which
Okay,
is
which is 7.
7. Right.
Yeah.
Yeah.
Okay.
Okay,
Good.
great. Okay, so now with the way this works, this new thing called bit papers, my writing is ridiculously thick. So I think what I need to do is I need to actually erase this. Otherwise, we're going to have a problem. Like I'm not going to have space to work.
Yeah.
So I'm going to have to erase all Seth's wonderful stuff. I have a completely different approach. What I do is I start at the end. I start backwards, and a lot of times I find starting at the end of a problem, starting backwards really helps. What I would have done is I would have said, "What's the average of X, Y, and Z?" And boy, I need a way to write. This is crazy. This is totally crazy. I need a way to write. I would have said that the answer is X plus Y plus Z divided by 3. That's how I would have started. Okay,
Yeah,
and then I would have said, oh, X is M plus 9 divided by 2. Y is 2M plus 15 divided by 2. And Z is 3M plus 18 divided by 2. And then I would have remembered all divided by 3.
Yeah.
And then it would have been in front of me better. Okay, then it
Yeah.
would have been sticking with me in the face. Seth was weird writing numbers and dividing by 3 there. He was very, you can easily make a mistake. But do you notice how Seth started with the definitions of X, Y, and Z? I'm starting with the answer.
Okay, but the truth is, I read the question, and I knew when I started with X, Y, and Z. When I started speaking that, I had already read that the question was to find the average of X, Y, and Z.
I know.
And so I knew to get the average of X, Y, and Z, I had to know in this problem, we are asked to find the average of X, Y, and Z. To do that, you need to know what X, Y, and Z are.
That's not the point. That's not the point I'm making. I'm making to keep things straight and to do the problem better.
Yeah, I know.
It's better to present the answer first rather than try to write down the early stuff. This way you have the answer in front of you. And then you do the calculations. The calculations are the minor part of the problem. You are making, and then you go from here, and then you can do this any way you want. Maybe to be careful, you would do M plus 9 plus 2M plus 15 plus 3M plus 18, then divided by 2, and then divided by 3. I'm sorry, my pen is so schlocky. Because and then you can add up the M's to get 6M. And Seth was also doing weird stuff where he was dividing the M's by the thing first. No, leave it all together. And we have a calculator, so we know that that's 42. Divided by 2, divided by 3. Notice again, one step at a time, no rush. This is 3M plus. This is 3M plus, 42 by 3. My brain is shot. Don't forget, it's getting late in the test here. 42 divided by 3, I have a calculator, is 14, okay? And then, 14, that's impossible. Oh, this is a 2. I can't even read my own handwriting. That's a 21, right? Okay? Can't even read my own handwriting. And then it's divided by 3. Notice I'm doing it very organized and one step at a time.
Yeah. I just love to add things. I love to add things in a column.
Fine.
Like 1,
you can add things in a column, 2, and you got the wrong answer.
And 3.
Fine.
And 19. 15 and 18.
Yeah, but you still got the wrong answer.
Yeah. 9.
Okay.
9. Yeah.
Okay, but you see the way this is the one step at a time, very organized, very like that.
But one step, but the 2 steps. They're 2 steps, and indeed, I just what I did was I went from silently thinking of first what should the answer be? What is the answer? And second, how do you get the answer? I unroll that, because when you do the calculation, the second step is actually done first. Right? Your first step is to is to write down x plus y plus z over 2, right? However,
No,
in
x
order
plus
to
y plus z over
before you
3.
calculate x plus y plus z over 3, I meant you have to find out what x, y, and z are.
Yeah, but that's a detail in the scheme of things.
Well, details are what you have to carry out the details correctly.
Yeah, but if you don't get
unlike what I did, you have to not make mistakes.
But you got the main point wrong. I mean, you got the main point right, but the way you wrote it was hard to follow.
Well, I'm sorry.
No. It's good you made a mistake. It's good you made a mistake.
Yeah. Now, there's another principle which is helpful to learn from this problem. And it's a widely applicable principle. And it goes like this. If you have, several different collections of quantities, right? And you take the average of each one. And then you take the average of all the averages. You get the same as if you took the collection and combined them, took the collections, the multiple collections, combined them all into one collection and took the average of everything in there.
Okay.
So the reason you could prove that this is true by generalizing the calculation that we showed you.
Yeah.
But you might have known that ahead of time. Yeah, if you realize that ahead of time, you could have simply added the 3 values, x, y, and z, that they gave you. Added, not the averages, but added.
Yeah, m plus 9, 2m plus 15.
Yeah, m plus 9,
2m
2m plus 15,
right.
and 3m plus 18. Add those 3 up. There are, the average. So there are 6 quantities. There are 6 quantities. M is 1, 9 is 2, 3m is 3, 15 is 4, 3m is 5, and 18 is 6. You add up those 6 quantities, divide by 6, and get the answer.
That's right. You could have done it that way. Yeah. But very few people probably would have done that. But yeah, you could have done it that way too. Okay, we are going to break this video. Eliav made a comment, and we have to change the video. We'll add in his comment. He had a great idea. He said that you can let m, and this has to be true for all m, so make m 0 and see what happens. Well, if m is 0, then you have 9 plus 15 plus 18 divided by 2. Oh, this is a calculator question. So I don't know what that is. That's 24.
Yeah.
24.
Why divide by 2?
Because first you have to find the average of m and 9, m and 15, and m and 18.
Well, then they add them together.
Yeah, we're adding together and dividing by... Oh, wait, this is 18. So that's 42. So it's 42 divided by 2 is 21, right? And then you have 3 of these things. What's the average of these in terms of m? 3 of these. You have 3 things that you're averaging, so you divide by 3 and you get 7, and that's the only answer. And Seth pointed out that you can get away with this because these numbers are unique. If you had a 2m plus 7, then this method actually would work. Because m is 0. So, but it's a really, really clever way to do the problem. Wow. Thank you, Eliab, for pointing this out. You have to sort of keep track what to do, right? You take half, and then they're taking the average of 3 things, so then you have to divide by 3.
Yeah. So what I'll write down to so you could read what the clever observation was. It's like this: when m.
So, but don't repeat what I did.
No, I'm not.
Okay,
when m equals
add something
0.
new to it. Add something new to it.
I'm writing on the slide a written form of the main observation. When m equals 0, the choice is A, B, C, and D are all distinct.
Yeah, we said that.
But no, I know that's okay. But the point is to write it down so people could write it down.
But we said it.
So it's in written form.
Okay, fine, but we said it. Come on, we done?
Okay.
Okay,
done.
we're done. We don't have to make a big deal about this. There was
now,
another.
Should I talk about my blunder?
No. Oh, that was why we were going to do this. Oh my goodness. Yeah, that's the more important thing. Yeah, this is really serious. Seth made a mistake, and I agree to it. Okay, Seth. Yeah, go ahead. Say your blunder, but say it quickly.
Last video.
It's the same video. Remember, it's the same video. It's being spliced in. It's the same video.
Okay, here we go.
Go ahead.
So earlier in the video.
Earlier in the video, right.
Earlier in this video, we did the following. The average of M and 9 is M plus 9 divided by 2. And that is called X.
Seth, just say what your blunder was.
I am going to do that. We said Y equals...
Seth, people have more... No one's going to watch all the detail. Just say what your blunder is. No one's going to watch all the stuff.
Well, if they don't want to watch it, they could forward. Go ahead.
No, but say the blunder, and then people can leave. Okay, say the blunder first.
I declared that if you have several collections of numbers, right, and you calculate first the average for each one, and second, you combine them into one big collection and take the average of that. I asserted that the two averages, the average of the averages and the average of the whole of the combined collection are equal.
Right.
That is not true.
That's right.
In general. It only is true when each of the collections has the same number of elements. Okay. So should I give an example of when it's not?
No. Oh, no. Can I give the example?
Okay, give me your example.
I'm going to give you a very, 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 very practical example. Okay? Because I just did this with someone. I literally just did this. Okay? This is such an impractical example. A person came by with his or her test. Okay? No. I was helping someone study for a math test. Okay? And here we go. They were like all these pages, right? And there were 4 pages of questions. And the person wanted me to grade the test. So this page had 1, 2, 3, 4 questions. This page had 2 questions. I'm making this up. This page had 3 questions. And this page had 5 questions. 3, 4, 5. Now, we went through each page, and I graded each one. I said, on this page, you would get an 80 on this page. On this page, you would get a 50. On this page, you would get a 90. 90% correct. And on this page, you would get an 80 again, right? So I said, let's see what you get on the test. Let's average the 80, the 50, the 90, and the 80 to see what you get on the test. That's what Seth is saying you can't do. You can't average 80, 50, 90, and 80 because there aren't the same number of questions on each page. If this page had 4 questions, and this page had 4 questions, and this page had 4 questions, then you can say, well, the average that you're going to get on your test is the average of 80, 50, 90, and 80, right? But only if you have the same number of questions on the page, okay? That explains it all. Okay? I think we're done, right? Seth was claiming before, his claim before was that this thing here, the way this is, right? If you get an average here of 80, 50, 90, and 80, the average of the whole test would be the average of 80, 50, 90, and 80, which is wrong. And that's what Seth's claim, and I agreed. schmuck I was.
Okay. Here, what I wrote in red is a much smaller example.
Yeah.
We have, let's call the score of a test. A score on one page is 1, and on the second page we have 2 scores of 2 and 3. The average of 1 by itself is 1. The average of 2 and 3 is 2.5. The average of the averages is 7/2. But if we combine 1, 2, and 3 together, the average of that is 1 plus 2 plus 3, which is 2. And 2 and 7/2 are not the same.
Okay.
However, if I did say,
Okay.
1 and 7 and 2 and 3, then the average of 8 and 2.5, the average of these would equal the average of 1 plus 7 plus 2 plus 3 divided by 4.
Yeah.
And that works because the number of numbers, 2 numbers each. Yeah.
Okay.
So
okay, we're done.
That's it.
We're done. Okay,
Yeah.
so this is spliced in somewhere in the video. Whenever we make a mistake, if we are lucky enough to catch it, we correct it. Okay, take care. Bye bye. Yeah.
Okay. Again, I wish we could take a survey. I think what the educators they ought to do is actually do a survey, a test, and ask the kids who take the SAT question, would you do it this way or would you do it that way?
Right. Well,
or do more work and have kids do the SAT questions while speaking into a microphone and getting recorded about how they do it.
Well, if we ever become cult figures and there's a demand for us to do this thing live, and we have 1,000 people watching us on YouTube, we can do that. But now,
we could maybe even do an online online show off. Have 1,000 people doing the same question.
Yeah. We don't know. Maybe. But things to think about. Okay, everyone. So I think we're done, right?
Yeah.
I think so. Okay, so Seth, you made the mistakes. It's good. I presented it differently. I approached it differently. This is good. You saw different approaches. This is really good. Okay, everyone. Have a great day. And like us, dislike us, give us comments on how we can improve our product for showing you, hopefully helping you understand, helping you approach math problems. Okay, everyone. Have a great day. Bye.